Assalamu alaikum. Our today's lecture is about sigma and pi bond. Sigma and pi bonds. Now, as we have already discussed the orbital concept of a covalent bond, I have told you that a covalent bond is formed between the is it formed by the overlap of the half-filled atomic orbitals, which then merge together to form a molecular orbital. Now, as far as this covalent bond is concerned, and we see that the overlap takes place between the half-filled atomic orbitals. Now, the strength of this covalent bond, the strength of the covalent bond or the molecular orbital, which is formed by the overlap of these half-filled atomic orbitals, it depends upon the extent of overlapping. That means if the extent of overlapping is greater, there will be greater lowering of energy, or maximum amount of energy will be released, and in that case the bond formed will be stronger. Now, if the overlap is minimum or the extent of overlapping is minimum, in that case the energy released is very low, and the bond formed will not be stronger. It will be rather weaker. Now the extent of this overlapping or extent of overlap of these half-filled atomic orbitals, it depends upon the orientation of these atomic orbitals, these half-filled atomic orbitals which participate in overlapping. Now, depending upon this their nature and the extent of overlapping, this covalent bond, the resulting covalent bond is of two types. We have got a sigma bond and a pi bond. Now, as far as this sigma bond is concerned, in a sigma bond we see that the bond is formed by the direct overlap, or the axial overlap of the half-filled atomic orbitals. Since the overlap is direct or it is head-on overlapping, so the extent of overlapping is maximum, and there is greater lowering of energy, and as a result of in this the bond formed is strong, and moreover there is high electron density along the internuclear axis, that is the line joining the two joining the nuclei of the two participating atoms which are involved in the covalent bond formation. Now, we have got this in this sigma bond, it is formed by various types of overlaps. We have got when there is overlap, this type of bond can be formed by SS overlap. That means the S atomic orbitals are involved in the overlapping. As you know that this orbital, it is this is spherically symmetrical, and the electron density is uniform over the entire this sphere. So we see that there is the overlapping is direct, or it is maximum or head on, and the bond formed is a stronger, it is stronger. So this is SS type of this sigma bond. Then we have got another type of this sigma bond, that is formed by the S atomic orbital and the P atomic orbitals. As far as these P atomic orbitals are concerned, as you know that these are dumbbell shaped, and the electron density is concentrated at the lobes. So again we see when the p orbital and s orbital, when they approach each other, when there is axial type of overlapping. Now in this case again there is maximum overlapping, and the bond formed is a stronger one, and it is sigma type. Now this sp overlap we can see in case of this is in case of this hydrogen fluoride. We see that s orbital, 1s orbital of this hydrogen atom is involved, and the 2p-z orbital of this fluorine atom is involved. So this is sp type of overlap. Now as far as this ss type of ss overlap is concerned, this we can see in the formation of hydrogen molecule. One s atomic orbital of one hydrogen atom merges with the or overlaps with the 1s atomic orbital of the other hydrogen atom. Then we have got another type of this sigma bond, which is formed by pp overlap. Again in this case there is an axial type of this overlapping, or head-on type of overlapping, and the bond formed will be maximum. So and the bond for and this the extent of overlapping will be maximum, and the bond formed will be stronger. Now you can see here, this is pp type of overlap. Now this we can see in the formation of this chlorine, where 3p Z of one chlorine atom, it overlaps with the 3p Z of other. Or similarly in case of fluorine, we have got 2p Z of one fluorine atom and 2p Z of other fluorine atom. Now as far as the relative strength, this since there is greater lowering when the extent of overlap is maximum, there is greater lowering of energy, and the strength of the bond will be more. Now as far as this relative order of strength, as a relative strength of these three types of sigma bonds is concerned, we see SS overlap, this bond formed, it will be stronger than SP overlap. Similarly, the SP, this bond which is formed by SP overlap, it will be stronger than PP overlap. Then we have got another type of this bond that's called as pi bond. Now this pi bond, it is formed by the sidewise or the lateral overlapping of the half-filled atomic orbitals. Now, this type of bond is formed by those p orbitals. It is mostly formed by p orbitals, and those p orbitals which are parallel to one another and perpendicular to the internuclear axis. Since in this case we see the overlap is it is sidewise or it is lateral, so overlap is minimum, and lowering and the less energy is released, and the bond would be it would be weaker as compared to the pi bond. Now as far as this sigma bond is concerned, sigma bond can be present alone in a molecule, whereas this pi bond cannot be present alone in a molecule. It can be present in addition to this sigma bond. Now now uh, uh, now you can see here, this is a p, these are the two p orbitals which are involved in overlapping. You see, these are perpendicular to the internuclear axis, and moreover they are also parallel to each other. When they approach each other, they overlap laterally or sidewise, and they give rise to the they give rise to the formation of this pi bond. Now this pi bond can lie since this both lobes of these p orbitals are involved in overlapping, so this bond can lie above and below this internuclear axis, while as in case of sigma bond, we see only one lobe of this p orbital is involved in this involved in overlap. Now you can see, if we make a comparison between sigma and pi bond, as I have told you that a sigma bond, it is formed by the axial overlap of this formed by the axial overlap of the atomic orbitals, whereas this pi bond, it is formed by the sidewise overlap of the atomic orbitals. Number two is that the overlap, since in this case the overlap is very large, and the bond is quite stronger, whereas in this case we see there is lateral overlapping, and the extent of overlap is less, so it is comparatively it is weaker than sigma bond. Then in case of this sigma bond, we see that s orbitals can take part in sigma bond formation, whereas in case of say s orbital as well as p orbitals, whereas in this case pi bond, we see only p orbitals are involved in case of this overlapping. Then we have got now the electron, as far as the electron density or the electron cloud is concerned. In this case we see the electron cloud of the molecular orbital resulting from the overlap of the two half-filled atomic orbitals, it is symmetrical around the internuclear axis. That means there is a high electron density along the internuclear axis, whereas this pi bond, we see that the electron cloud is unsymmetrical, rather it is present above and below the internuclear axis. The molecule cannot have free rotation around this pi bond, whereas in this case we see free rotation is possible, since the bond is formed along the internuclear axis. Then we have got one more difference between the two, is that this bond, as far as this sigma bond is concerned, this bond can be present alone in a molecule. That means in absence of pi bond, sigma bond can be there, whereas this bond cannot be present is not present alone in a molecule. In absence of this sigma bond, in absence of sigma bond, pi bond cannot be formed. Then we have got one more difference between the two, that as I have told you that that the free rotation of the atoms around the sigma bond is possible. The reason is that the electron density lies along the internuclear axis, whereas in this case we see the free rotation is not possible around the pi bond. The reason is that this bond is formed above and below the internuclear axis. So this is about the orbital concept, as far as the orbital concept of this covalent bond is concerned. So we have got these two types of bonds, that is sigma and pi bond. And so this is for today, and in our next lecture we will take up this molecular orbital theory. Thank you very much.